Welcome to a new video. This is Mo from APC Mastery Path, and I'm glad to be a presenter in this video. Today, we're going to be discussing how you can build your own customized retrieval augmented chatbots using Chainlit as the front end and making the best use of local large language models such as Phi3 and Mistral from Ollama, and then we're going to be using Llama 3 powered by Groq. I've made a previous video, which I'm going to be putting the link in the description below, about how you can deploy retrieval augmented generative chatbots locally on your machine. They're not fully customized, they are off-the-shelf products which you can use directly and without any sort of preparation. In today's video, we're going to be exploring what are retrieval augmented chatbots, and then we're going to be exploring the requirements for the customized chatbot that we're going to be building. And lastly, we're going to be exploring the code behind building that chatbot. So we need first to understand what is a retrieval augmented chatbot. A retrieval augmented chatbot relies on having a wide variety of them files. They could be Excel sheets, PDFs, CSVs, and the likes. And then the text data from all of these files is combined together into one huge variable. This variable is then dissected into smaller chunks, and then these chunks pass by an embedding model which converts the text values into numerical values. The numerical values are then stored in a vector database. And then the end user asks the large language model a question. The large language model then goes to the vector database to retrieve the nearest answer that fits the question or the query of the end user. And that's simply how a retrieval augmented generative chatbot works. In order to build our own retrieval augmented generative chatbot, we need to have some requirements that are installed in place. The first one, as you can see on the screen, is Ollama. If you go to ollama.com, you can then download Ollama as a piece of software, and it's available for all of them platforms: Linux, Windows, and Mac. The second requirement definitely is a programming language, and our programming language of choice is Python. You can go to python.org/downloads, and then you can download your preferred version. The version that I'm going to be using on my machine is 3.11.5, but you can use whatever version you please. The third piece of software that is going to be used today is an integrated development environment. My IDE of choice is Visual Studio Code. You can use Anaconda, you can use whatever you please, but that is what I'm going to be using in today's video. And now let's start exploring further how we can build that chatbot. So in order to give people credits, I've been inspired by a channel called Data Insights Edge. I'm going to be putting the link of the channel in the description of the video below, and let's explore together what packages we need to be installing after installing Ollama, VS Code, and Python. The first package that we need is called Chainlit. Chainlit allows us to build the front end of the chatbot. LangChain and LangChain community, they allow incorporating large language models within our own applications, and it allows us to chat with the models. PyBDF is quite an important package that allows us to parse PDF documents and extract the text from them to be used further. Chroma is quite an important package which allows us to store the numerical values of the embeddings in a vector in that database. Groq, we're going to be deploying that in Llama. We're going to be using Llama, where we're going to be using the API from Groq for faster computing. Ollama, we've already covered that we're going to need to install it from ollama.com. Python-.env, that's going to be quite useful if you're going to be having a separate environment where you're going to be putting the API keys and lots of secret information. So you can refer to that environment and get the data from it as the .env file into your application. The sentence transformers, that can be vital if you're going to be using embedding models from the Hugging Face website and not using the embedding models from Ollama. ENOPS, it is a dependency and a requirement by sentence transformers. So having installed all of the packages, we can then import them in our model or on our app. So the first one, we're going to be importing Chainlit, followed by PyBDF. OS is going to be quite vital if you're going to be using a separate environment and then importing the API keys and the likes from it. NumPy is used for dealing with arrays and vectors. and then requests that's going to be done as a part of the chat application itself, or chatbot. A synchronization or a sensio, which is going to be used for the callbacks, which are going to be embedded in our model or in our app. As we've explained above, Groq is going to be quite important for dealing with API keys from Groq itself and cloud computing for Llama. And then we're going to have some embeddings from LangChain, the text splitter for splitting of the chunks, and then the vector database in order to make sure that we store our embeddings somewhere. And then it is quite vital to have a conversational retrieval chain so that we can have this line of conversation with a chatbot. Chatbot Ollama, that will allow us to import models directly from Ollama and deploy them locally in our machine. And then some dependencies for having a chat history, which is gonna lift up the GUI of our chatbot. Hugging Face embeddings, that is vital for me because I'm going to be exploring with yourselves today how we can use both Ollama and the Hugging Face in creating the embeddings. And lastly, the C transformers, that is quite vital for importing large language models from the Hugging Face website. So we're going to be discussing how we can make the best use of embedding models from Ollama and Hugging Face website, and also large language models from Ollama and the Hugging Face website. And now let's move forward to how we can create the graphical user interface for our chatbot. So we're going to be initiating with understanding where to store the files that are going to be uploaded. And then we're going to try to make it a little bit easy for the eye and intuitive for the user by adding a message of please upload whatever file you want. And in this chatbot, we're going to be accepting only PDF files. We can here explore the maximum size and layout and also the maximum number of files. The timeout is quite important if the user did not provide any sort of response. So we have set it here to 180 seconds. And then we're trying to make it a little bit easy for the eye by adding an image so that the end user can know that there's something that is happening in the background and that processing is being done. And we have added also the word processing plus the file name itself. Here comes quite an important part or a step, which is processing the files that we have uploaded. So the first thing is we allocate the files uploaded to specific variables, and then we apply the PyBDF package to it so that we can parse the text input in that file. And that's what we have done. So we have put the file and its path in a variable, and then we deploy the PyBDF package, and then whatever text, extract it and put it in another variable. And then this text is going to be split using the recursive character text splitter. And then we have chosen, or I've chosen, a chunk size of 350 and a chunk overlap of 50. That's going to be different from one person to another, depending on the actual GPU that you have. In my case, and in this video, I chose some sort of like mid-range chunk size and a mid-range chunk overlap. As a rule of thumb, for my GPU, I could have used anywhere between 500 to 1500 in the chunk size and 10 to 15% of that in the chunk overlap. And then adding some metadata so that we make things a little bit rich if we want to debug in the future. Having finished the importing, let's do the embedding. So you can do the embedding using Ollama embeddings here. I'm commenting these lines because I found out that on my computer, the Ollama embedding model, which is nomic embed text, is quite slow. It takes about 5 minutes to do the embedding of a 13-page document. So I opted to use the embeddings directly from the Hugging Face website using the same exact model, and it was instantaneous. When it comes to the embedding, it took about a couple of seconds, which is understandable. Once you have imported whatever model you please, whether it's from Ollama or from the Hugging Face website for the embeddings, you can then make the best use of the actual numerical values for the embeddings, collate them together in a Chroma database. And here we initiated a chat message history that is going to be referenced here. And then we're going to be splitting whatever we give the chatbot and whatever we receive into a chat history and an answer. And then moving forward, we need to have a whole chain of thoughts. So the whole chain of thoughts takes into account whatever model you have. In here I've used the Chat Ollama, Mistral, and whatever you have developed in the memory, which we have done above. And in here we are trying to give the end user the reference from the source documents, as you can see here on the screen. You can be using here as well. Instead of Chat Ollama, you can specify whatever model you need from the Hugging Face website, and I'm going to be showing you this in a bit. And once the embedding model undertook the chunking and embedding of the chunks, and the large language model did its work, we are giving the end user a message that's saying that processing is done, and now you can ask your questions. So if you have a specific model that you have in mind instead of Chat Ollama, so you can replace this line of code with here. You can specify what model you need. In here I used the C Transformers package to import large language models from the Hugging Face website. So you need to specify the repository in the model, and then how many tokens, what is the temperature, which dictates what is the actual creativity of the model, and then you can import this model here using that line. The LLM is going to be equal to whatever LLM that you're going to be importing. And that's how you deploy large language models from the Hugging Face website in your chatbot, and use as well Ollama. And here comes the last step in the creation of that chatbot, and then we're going to be exploring what happens. So that last step is all about building the conversational memory in the chatbots, handling the source documents and handling any errors. So that is pretty conventional stuff that you can find in the documentation of Chainlit in order to understand how to handle the callbacks and error handling. So I'm going to be focusing on these ones. So we have now an answer that is going to be stored in a variable, a source document, and some text elements as well. And then we're making sure that we're providing the end user with the naming convention of the source documents so that they could understand how good or bad the large language model has performed. And that's exactly what we're doing here. So we are trying to understand what is the source document and providing the content as well of what has been passed. And then we're providing the name itself in here of the source document itself, or the source page. And then we are compiling them all together in here, compiling the answer and the source documents in one response. And then it's now time to understand how we can deploy that and see the end result. One last step, and that's when you're going to be deploying Llama using Groq. So you have to specify the API key that you're going to be generating from the Groq cloud. And by the way, it's free of charge at the time being. And then you're going to be naming a variable, which is a Groq API key. And then you're going to be defining what exact model you're going to be deploying from Groq. I think Groq has a plethora of the models, so you need to be specifying what model, what is the temperature, and the likes. And then if you scroll down and go to the retrieval chain here, you have to specify the LLM as LLM_Groq. It's the same exact step that we did with Phi3. And now it's time to deploy everything together. In order to deploy whatever we have created in that app, we need to activate Ollama first and pull the necessary files or models from it. So in order to do that, open command prompt and then type Ollama pull and then the name of the model that you need. So the first one is the embedding model, which is nomic-embed-text. It's going to take you some time to download the model in the first place. I've downloaded it. As you can see on the screen, it's 274 megabytes and some change. Also, we need Ollama pull Mistral. So I have downloaded it already. As you can see on the screen, we have 4.1 gigabytes. So it's going to take a little bit of time at your end until it is deployed. Also, you can deploy whatever models you want. So Ollama pull Phi3, that's the latest one, which is provided from Microsoft. And that is the small one. I think it's a 3 billion parameter model. We can also deploy Ollama pull Llama 3. As you can see here, you can pull whatever models you want, and they're going to be running in the background and ready to be deployed. And then one of the efficient models that we can also deploy in the embedding is called the all-mini LM. So we can deploy it like that, Ollama pool all-mini LM. And then that one is quite small, 45 megabytes, but it's quite handy if you don't have the GPU required or the CPU required for handling huge tasks. So in order to deploy whatever we have built before, go to the place or the directory we have saved all of them files, right click anywhere and then open in terminal. You're going to be greeted with a command prompt with the same exact directory we have saved your files. So let's crack on with the Mistral one here. So Chainlit run Mistral Chatbots _ Mistral .py, and then you press enter. You just wait for a little while. It's going to deploy everything and show that to yourself in the browser, as you can see here on the screen. So that's the beginning. So please upload a PDF file to begin. Let's browse here, and then I'm going to be using one of the PDFs of my choice, which is my RICS submission, and that's going to take a little while to process using the local embedding model, which is nomic-embed-text, and that's now done and dusted. As you could see, it took about a minute or so, and that's 13 pages. So now let's ask a question, which is from the document provided, give me an example of data management. And that is one of the areas of the competencies in the RICS submission that an APC candidate would have to have. So pressing that, and again, that is on my local computer. I'm not using any sort of cloud computing or any sort of other solution. It's going to take a little while, and that's it. So as you can see, it's pretty fast. I haven't cut the video, so it's pretty fast using Chat Ollama Mistral model. So it gives you on the right as well the sources, which is pretty decent. It's pretty accurate as well. I'm really happy with it. Let's ask another question to make it a little bit challenging. So from the document provided, give me an example of procurement and tendering level 2, because there are 3 levels for different areas of competencies. So I just want to challenge the chatbot a little bit to make it a little bit challenging and understand how accurate or inaccurate it is. And that is pretty decent, to say the least. It provided that in a 2-stage procurement route, the first stage involving blah blah blah, and a contract administrator blah 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 blah, which I could say it's accurate, because that is the stuff that you're going to be awaited to write in your submission, that you have done, you're knowledgeable, and then you have done it. So let's try another chatbot. And now let's try the Groq one, because Groq is much faster than that one as well. So let me copy the name to make it easier for me when I'm typing. Open in terminal, and then here we're going to be writing Chainlit run Llama Groq, and then wait for a little bit. It's going to open a new window in the browser. We're going to be doing the same exact file. It's going to take a little bit of time to process or embed the document and store the chunks. So that's now done and dusted super fast. I'm happy with that. So let's ask the same question from the document provided. Give me an example of procurement and tendering level 2. And it's much faster, definitely 100%. However, the quality of the response is not great. It's much faster, but it's not great. But we can change the model in Groq to be the 70 billion parameter model, not just, as you can see here, it's LLM Groq. We can change that one above to be the 70 billion parameter rather than the 8 billion parameter. So in my case, it worked fine locally on my machine using Mistral from Chat Ollama, and I could even use the Mistral, which is from the bloke on the Hugging Face website, and the timing convention is nearly the same. And that's basically it. That's how you can deploy that chatbot and use it for your own benefit. And And that's how you can deploy a wide variety of large language models in your chatbot. You can even think further about fine-tuning large language models and use the fine-tuned models for your own benefit in the chatbots. You can have a wide variety of use cases. Think of bidding, think of CVs, think of other documents that you can extract data from them. At ABC Mastery Path, we try to use the latest technology and marry it with conventional ways of teaching to provide an enriching learning experience. Do not forget to visit my website www.abcmasterypath.co.uk for personalised and customised mentoring and teaching packages for the RICS ABC candidates. And that's all for this video. Thanks a lot for watching and catch you in the next one. Cheers guys.